Okay, I'm going to go to the whiteboard to do this one over here. And the reason for that, it's going to take a little time to explain what I'm doing. And certainly, I'm not going to say it's the best approach, but it's the approach I'm taking. So let's go to the whiteboard. And when I do the whiteboard, what I'm doing is I'm actually just looking at this over here. And I do want to write it down as a summation problem. My goal is to write a sum down. That's my goal. All right? So let's do that. And the first thing I'm noticing looking at this thing over here, let me write this down. It's 5 plus root 6. And the bottom is root 2 plus root 3. Plus, the next term is 7 plus root 12. And then root 3 plus root 4. Then they got this yada, 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 which means it's predictable. And they got 63 plus the square root. This is kind of crazy over here because it's 992. I don't recognize that at this point. And on bottom, I get root 31, and I get a root 32. So I'm going to say looking at it, and I always say chase one rabbit at a time. I'm going to start counting somewhere. And someone says, what do you want to start counting from? I'm just going to start arbitrarily counting from the number 2. All right? So I'm going to write down n equals 2. And the first thing I'm going to do is just write down that. And that looks like I'm going to do an n over here. And then it's going to be 2, 3. It goes up by 1, right? And it stops at 31. Plus, I'm going to get the next guy, and this guy over here. That looks just like the root of n plus 1. Let me see if that's true. 2 plus 1 is 3, and then 4. And then if I get to 31, 31 plus 1 is 32. Looks pretty good. Let's look at this guy over here, a little more complicated. And that's 5. All right, so I'm looking at that. And it looks like it's going up by 2. So it has something to do with 2n. But I need to, make sure it's going to give me that. 2n, that would be 4. I have to add 1 to that to get the 5. Let me just see if I get the next term, which would be 3. 2 times 3 is 6. 6 plus 1 is 7. Good. Let me see if I get the 63. 2 times 31 is 62. And 62 plus 63. Now I got this guy over here. It looks a little more complicated to me. All right? It looks more complicated to me. Plus, it's a root. And I'm looking at this. It's 612. But this 992 is killing me. All right? And I'm starting to think that maybe it's a product of two numbers. But I got to check it out. I'm not really quite sure about that. I'm going to say it looks like, 6 looks like 2 times 3. So it looks like 2 times 3. Now we give it a 6. This is 3 times 4. I'm going to say 31 times 32 is this over here. Let me check this out, though. 31 times 32. All right, let's write this down. 31, 32. Well, you get 32. 3 times, 0. 6, 9. You get 9, 9, 2. Wow, that worked out beautifully. So it does look like that. It looks like it's just n plus 1. So I got my sum. All right, once you get your sum, let me get this eraser out, just my little check work. Once you get your sum down, I'm going to manipulate the sum end. And to do that, I'm kind of looking at it, and I'm going to, just work with this over here now. I want to see if I can get that a little bit simpler. So it's 2n plus 1 plus the root n plus 1 over the root of n plus the root of n plus 1. Well, I'm going to multiply the bottom by its conjugate, and it's going to simplify nicely, by the way. Now, the bottom simplified nicely. I'm wondering about the top, by the way. I'm really wondering about that. Now, what do you get in the bottom? You're going to get n minus n plus 1. I'll do that later, by the way. Now, I'm doing the top. It's going to be, well, I got to write this down. I mean, not much else I can do about this over here. It's going to be 2n plus 1 times root n. I'm doing this times that. Plus, well, root n times the second term is going to be n root n plus 1. That's not so bad. And now I'm going to do this over here. And what are you going to get? You're going to get minus 2n plus 1 times the root of n plus 1. All right? And then I'm going to do this times that, which is going to give me minus, let's see, n plus 1 root n. All right. Boy, that doesn't look good, does it? Let's see if we can maybe combine things together. And I'm going to look for like terms. I'm going to say this term and this term. Oh boy, I think I can add that together. And what do you get there? 2n plus 1 minus n minus 1, which is going to be n root n. Right, so I just did these two over here. So, 2n plus 1 minus n minus 1. Yeah, it looks pretty good. And then I'm going to do these two over here. And what do you get there? Let's see. It's going to be n minus 2n minus 1, which is going to be, let's see, that's going to be minus n minus 1. So I can put minus n plus 1 and root n plus 1. And what do you get on bottom? N minus n is none. Oh, you get minus 1. So what do you get over here? N plus 1 root n plus 1 minus n root n. That's not so bad. So I'm going to write my sum down now. And I'm writing this sum over here again. A simple form of it. So the sum, n equals 2 to 31, of that nightmare, which was 2n plus 1, plus the root of n plus 1, over root n plus root n plus 1, now can be written this way. By the way, it may not be easier, but I'm going to hope it works out nicely, but it looks like it might be telescoping. And this will be n plus 1 root n plus 1 minus n root n. All right? So what I like to do is I like to write things down, and I'm going to start with 2. And what do you get? You get 3 root 3 minus 2 root 2. I'm going to put the next one down. That's going to be, I'm going to 3 now, right? So 4 root 4 minus 3 root 3. Put the next one down. You get 5 root 5 minus 4 root 4. I think you get the idea that this is going to go on and on and on, but we are going to stop somewhere. Where do we stop? At 31. So it's going to be 32 root 32 minus 31 root 31. What's before this one? 31 root 31 minus 30 root 30, right? This is telescoping because we're starting to see things that cancel off. And let me go through the cancellations for you. This is going to cancel that. This will cancel that. There will be something here that cancels that, all right? Now looking at this, this cancels, and something's going to cancel over here, and everything in the middle disappears. And what are you left off with? You're left off with minus 2 root 2 plus 32 root 32. All right, looks kind of crazy looking, doesn't it? So I'm going to keep simplifying it. Minus 2 root 2 plus 32. 32 is actually 16 times 2. And the square root of 16 is 4. So you get 4 root 2. All right? What do you get here? Oh, boy. Minus 2 root 2. And let's see, 4 times 32, 128 root 2. And it's going to give you 126 root 2. All right? Now, granted, for a lot of people, these are difficult questions, and I kind of agree they are difficult questions. It depends what road you're taking to them. One thing I'd hate to see you doing, though, whoops, I'm going back too far, is to start simplify term by term. However, some people do that, and they do a nice job of it. I'm just looking for a generalized pattern, and the reason being is I'm looking, if this was a bigger number, I'd certainly want to be looking for a pattern to it and a simplification. I find it easier to simplify algebraic statements than numerical statements. But after I did that, I started to realize I had a telescoping series, which turned out really nicely, by the way. And we get a final answer over here, 126 root 2. And we're done. Thank you.